In the previous session, we had discussed about maxima and minima, relative maxima and minima. So in this session, we will be discussing a related topic called absolute maxima and minima. Okay, just like our one variable calculus. Okay, so I hope you remember the methods which were used in one variable calculus. In one variable calculus, basically you will be given a closed interval like this, maybe closed interval a b, and they will be asked to find the absolute maxima or minima in that interval. Okay, so when you study a maxima and minima, you know that there can be many maximas and minimas. Okay, so these points are actually maximas. So these are also called local maxima. So absolute maxima is basically the maximum of the local maximas. Okay, similarly we will have the concept of absolute minima also, which will be the minimum of the absolute minimas. Okay, so now in the previous session we have discussed ways to find these points. Okay, these points. Okay, so here we will be discussing ways to find the absolute maximum of those points. Okay, so there is nothing new to learn here. It's very easy. It is much more easier than local maxima and minima. So before that, you should understand how we had done this problem in one variable calculus. Okay, so in one variable calculus, you had an interval like this, and you were being asked to find the absolute maxima and minima in that interval. So what will you do? So it will contain two steps. In the first step, you will find the critical points. Okay, so what is the critical points? The critical points are points where f dash of x is equal to 0. Okay, so first step you will find the critical points, and the second step you will take the end points. Okay, so this was the case we had done in the one variable case. Then you will be making a table like this. So suppose you will be finding, if suppose x1 is your critical point, you will find f of x1, and if suppose x2 is a critical point, you will find x2, and suppose a and b are the endpoints, you will just find what is f of x1, you will find f of x2, you will find f of a, you will find f of b. Out of this, the maximum would be the absolute maximum, the minimum would be the absolute minimum. Okay, so this was the case which we had done in one variable case. So the same method will be done here also. Okay, so instead of an interval here, since we are dealing with two variables x comma y, you will be given a region in the xy plane. Okay, so a region can be a circular region, it can be a triangular region, whatnot. So it can be any region. So you will be given a closed and bounded region in the xy plane. Okay, just like an interval there, you will be given a closed and bounded region in the xy plane, and you will be asked to find the maximum, absolute maximum, minimum of a function in this region. Okay, so here also it will contain two steps. The first step would be you will have to find the critical points. Okay, you will have to find the critical points. I'll just explain it again. Okay, the first step would be the critical points. Second step would be you will have to find the end points. So end points in the interval was basically the just a comma b, but here the end points should contain this boundary curve also. Okay, so here the endpoints will contain this boundary curve along with this corner points. So here, since it is a region, this will have the endpoints would be this boundary curve plus these corner points. So if this is circle, the endpoints would be simply this circular plane. Okay, so these are the case. So here also you will have to find two things. First is critical point, and then the endpoints or the boundary points also. There also we will have to check for maxima and minima. And once you get those points, you will compare the values. You will take maybe f of a b, you will take f of xy, and out of them the maximum would be the absolute maxima and absolute minimum. Okay, so only the concepts which I have learned in the one variable calculus will be used here. It's much more easier than local maxima and minima. Okay, so this was the method which was done in one variable calculus, as I explained. You will find the critical points in a, b. Okay, then you will check at the endpoints a comma b. Then you will find the largest value will be the absolute maximum, and minimum, smallest value will be the absolute minimum. Okay, so same method will be actually extending to the two variable case. Okay, so what are the steps here? In the first step, you will do, if you are given a function f of xy and a region, suppose you are given a region R, first step is you have to identify the region. Just draw the graph of that region. Okay, so that you can identify the boundary points like that. Okay, so first step is just draw the region. Okay, in the case of absolute maximum and minimum. In the second step, you check for critical points by putting fx is equal to 0, fy is equal to 0, and getting xy. Just like our local maximum minima case, you find the critical points. Okay, so once you find the critical points, you write down it somewhere. Suppose you can make a table like this: xy, f of xy. Suppose your critical points are here 1 1. Just write 1 1 in the table. Suppose another critical point is 1 2. Just write 1 2 there. Okay, so form a table like this. Okay, now what are you going to do is that now you will check at the boundary points for extrema. Okay, now the boundary points, suppose if it is a square like this, the boundary points will be actually lying on this line segment, this line segment, this line segment, and also this line segment also. Okay, so we will be checking maximum minima along all the line segments. Suppose there is a point here where maximum minima can occur. I'll discuss that then. Suppose it is the point 3, 4. I'll write 3, 4 also in this table. Okay, and at the last case I'll write these corner points also. Suppose your corner points are 0, 0, etc. So I'll write 0, 0 also. Okay, so once I have written all these xy values in the table, I'll just find out what is f of xy. Suppose I'll just put 1 into f of xy, and I'll find out the value of f of xy, and I'll complete the table. Okay, and from that the maximum value would be the absolute maximum and the minimum value would be the absolute minimum. Okay, so here we will not be discussing about second, we will not take second derivative in this case. Okay, only what you will do is that you will just find the critical points, put it in the table, look at the boundary, put it in the table, look at the corner points, put it in the table, and then find the f values at the of the all the points in the table. So no second derivatives, just using first derivative itself we will be doing. Okay, so this question is very important. They can ask you one question for 7 markers because it is a bit lengthy, but it is very easy. Nothing new, no new concepts are being used here. Okay, now let us try one problem. Okay, how to find the absolute maxima and also absolute minima. Okay, so suppose you are being given a function like this. Just read the question. Find the absolute maxima and minima values of this function in the closed triangular region R with vertices 0, 0, 3, 0 and 0, 5. Okay, suppose it is given to you. Okay, the very first step is you have to draw this region R. You have to understand what is that region. So the first step is I'll just draw the region. Okay, so here is the region, I have drawn it here. This is the region here. You will have to find the absolute maxima and minima in this point. So I hope it is very clear how to, very easy to draw it, because you can just plot the points 0, 0, 3, 0 and 0, 5 and join. So this is my region. Okay, now what are the steps involved? Now I'll find first of all the critical points. First of all, that is the first step. I'll have to find the critical points. So what are the critical points here? So this is f of xy. Just find fx. What is fx? Fx is actually 3y minus 6, and find fy. Fy is actually 3x minus 3, and equate them to 0 to find the critical point. So from here we will be getting y is equal to 2, x is equal to 1. So you are just getting 1 point. So that is just 1, 2 is there. So that is your critical point. Okay. So in some problems you may have more than 1 point. So here is 1 point. So just write 1, 2. Okay. If you want, you can draw the table here itself. Okay. So suppose I'm drawing the table xy, f of xy here. Now I have got 1 point here, that is 1, 2. Okay, I'll fill the table again when I'll check the boundary regions also. Okay, now next what I'm going to do is that, so now we have found the critical points. Now we'll check along the boundaries. Okay, it's very easy. Now, so there are 3 line segments are here. This is one line segment 0, 0 to 3, 0. Then there is 0, 0 to 0, 5. Then there is a line segment 0, 5 to 3, 0. Okay, we'll check along the boundaries. Now I will tell you how to check along the boundaries. It's very simple. Take one boundary. For example, suppose take the boundary which is the line segment joining 0, 0 to 3, 0. Okay, so in that boundary, the idea is we'll write the equation of that line segment. What is the equation? Here, this is actually the x-axis. So the equation would simply be y is equal to 0. So the equation of that line segment is basically y is equal to 0. Or you can understand that just y is equal to 0 happens in that line segment. Okay. Now if you don't know how to write the equation, you can always use the 2-point form. Okay, you have studied in your lower classes. What is it? It is actually y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x. So from that also you can write the equation. For example, if you will put this point here, it will be simply be y minus 0 by 0 minus 0 is equal to x minus 0 by 3 minus 0. This is valid because don't be confused why 0 is the denominator. These are actually not numbers, these are ratios, so it is valid. So when you simplify, you will be getting y is equal to 0. So even if you don't know the equation, you can always derive the equation using this 2-point form. Okay, so this has the value y is equal to 0. Okay, now in this boundary, what will happen to my function? My function would become, when y is equal to 0, in that boundary only my function f will become, y is 0 here, so this will be 0, simply it will become minus 6x plus 7, because y is 0 in that boundary. Okay, so this is my new function now in the boundary. Okay, now I'm going to check for maxima, minima along that. So what will be the maxima, minima? Now you can see that this is basically one variable calculus thing. So if you have to have maxima, minima, your f dash should be 0. So what is your f dash here? Your f dash is equal to minus 6. So there is no maxima minima in this boundary. Okay, so we cannot find any maxima minima along this boundary. So no points are there except the endpoints. Don't forget to put the endpoints because you will be checking at endpoints in every problem. So the endpoints here are, you will also be checking at 0, 0, okay, 3, 0, just like your one variable. So you'll be checking at the endpoints, but inside, in between the endpoints, nothing is there because your f dash is not equal to 0. Okay, so if you have understood that, let us look at this boundary here. Let us look at this boundary. So in that boundary, can you tell me the equation? If you know that this is the y-axis, the equation would be simply be x is equal to 0. If you don't know, you can just apply the 2-point form to find x. Okay, now what will be my f of xy become? My f of xy will become, and since x is 0, it will become simply f is equal to, since x is 0, minus 3y plus 7. Okay, if you have to find maximum or minima, you should have f dash is equal to 0, but your f dash is minus 3, which is never equal to 0. So there is no maximum minima there. Okay, I hope that is also very clear. Okay, but don't forget to put the endpoints here. Endpoints is 1 is 0, 0 already I have put in the table, and there is 0, 5. Okay, now if you look closely, what are actually we doing here? You are actually, if in the boundary case, you are actually converting the two variable function into a one variable function. Okay, you are just removing either or x or y to make it one variable thing, so that you can use the concepts of one variable calculus there. Okay, so that is the idea here. Okay, so if you have understood the idea, now let us look at the third boundary. Okay, if you look at the third boundary here, okay, what is the equation of the third boundary? I don't know what is the equation, so I'll just write down the equation. What is it actually? It is, you have to try to find it out. So it is actually y minus 0 by 5 minus 0 is equal to, okay, x minus 3 by 0 minus 3. So what is it? It is actually uh, uh, minus 5 by 3x. Okay, y is equal to minus 5 by 3x minus 15, right? So y is equal to minus 5 by 3x plus, okay, so it is plus 15 by 3, so simply it is minus 5 by 3 x plus 5. Okay, so this is the value of y here. Okay, you just check it out. Please correct me if I am wrong. So I think it is correct. Okay, so this is the value of y. Okay, or you can write the value of x also if you want. Okay, so from this you convert this function into a function of one variable, just as I told you. Okay, so that you can use the one variable apply method here. Okay, so that was the idea here. You are making the two variable thing into a one variable case. You are simplifying that thing. So your f will become, what will your f become now? It will become 3 into x into minus 5 by 3 x plus 5, right? Minus 6 into x minus 3 into minus 5 by 3 x plus 5, right? Okay, plus 7. Okay, you just substitute it. Now you will be getting just a function of x here. Okay, suppose it's we have to simplify, you will be getting a function of x only. From that you can find f dash of x. If it is 0, there will be a critical point. If it is not equal to 0, there will be no points in between. And don't forget to put the endpoints. So I hope this is clear how to check the maxima minima at the boundary. Okay, so I hope it is clear. Just write down the equation of each of the curves, substitute into the equation to make it a function of one variable, put f dash of x is equal to 0, simplify to get the critical points. Okay, so we have enumerated all the steps over here. Okay, so I hope it is clear. Okay, so as I told you, you have to check each and every line segment. So when you took this line segment, you will be getting this equation. You will have to substitute in the given function, and when you substitute, please try to do it yourself. It will be simplified into this equation. Nothing new is there, just routine calculation. Nothing new is there. Okay, now if you have to check the critical points, your f dash should be 0. What is your f dash? F dash here is actually minus 10x plus 14, or the value of x would be simply, so f dash should be 0, so the value of x would be simply be 7 by 5. Okay, so maximum or minimum can occur at 7 by 5. So what is the corresponding value of y? Because you are taking 2 points here, so what's the corresponding value of y? The corresponding value would be, y would be minus 5 by 3 into 7 by 5 plus 5. So it is actually minus 7 by 3 plus 5. I think it is 8 by 5. 8 by 3, right? So the point there is actually 7 by 5, 8 by 3, 7 by 5. Okay, so it is wrong here. It is actually 7 by 5, so comma 8 by 3. So please correct it there. It is actually 7 by 5 comma 8 by 3. Okay. Okay. So I hope it is clear. So, and also you have to write the endpoints here. Okay, now our table is complete. You have checked all the interior points, all the boundary points, and all. We also have included all the corner points also. Okay, now what will you do is that you will just find out f of xy values. Okay, so you find f of 30, you find f of 05, again you find f of 75, f of 83, etc. So that so this way you have to complete everything. Just find out xy. This is our table. You take f of xy. Okay, so complete the table, and from the table itself you can read out the absolute maximum and minimum. Okay, so what is the maximum value over here? The maximum value is 7. It is happening at 0, 0. So the function has an absolute maximum at 0, 0, and the absolute maximum value is 7. Okay, and similarly, what is absolute minimum? The function has an absolute minimum value of minus 11 occurring at the point 30. Okay, so this is basically maximum minima. Definitely this question will be asked in exam for a 7 marker or 8 marker because it's a bit lengthy, but essentially it is very simple only. Okay, there is nothing new to do here. So I hope it is clear how to find absolute maxima and minima. Okay, so if you understood this, you could try this problem also. Okay, so before you try this problem, already everything is given to you here. So the already equation also is given to you here. They have told you that it's a triangular region bounded by these lines. If you want, you can have to draw it. Okay, you have to just draw it. Okay, so what is it? X is equal to 0 is actually this line, y is equal to 0 is this line, and y is equal to 9 minus x is, that means actually x was y is equal to 9. So basically it will be a region like this. Okay, so this is the region R. If you want, you can mark the points. It will be 0, 0 will be here. So here when y is 0, x would be 9, so it will be 9, 0. And when your y is x is 0, your y would be 9, so it will be 0, 9. So this is the region here. Okay, so what are the steps in? So we have drawn the region. What are the steps involved? First you find the critical points by putting f dash of x by putting fx is equal to 0, fy is equal to 0. What is fx is equal to 0? When fx is equal to, what is fx? Fx is actually 2 minus 2x. And what is fy? Fy is actually 4 minus 2y, right? So when you come equate to 0, you will be getting the value of x as 1, value of y will be 2. So only one critical point, that is 1, 2. Okay, so we can form the table, right? X, y, I have to got one value, that is 1, 2. Okay, next what you are doing is that you have to check at the boundaries. This boundary is actually y. Already they have given the equation of the boundary itself. Equation is y is equal to 0. So in that case, your f will become simply 2 plus 2x minus x square. Okay, you have to check for critical points here. That is your f dash should be 0. When is what is your f dash here? Your f dash is actually 2 minus 2x. Okay, so 2 plus 2x minus x square is equal to 0. Your f dash is actually 2 minus 2x. So when you equate it to 0, you will be getting the value of x as equal to 1. Okay, and when x is equal to 1, your y is correspondingly 0. So one other point is actually 1, 0. Okay, so that is there in that case here. Okay, and also don't forget to put the corner point, which is 0, 0. Okay, next look at this one. Put x is equal to 0, check it out, check it here also. So you will form a table, and from the table you can read out the absolute maximum and absolute minimum. Okay, it's very simple. We are not doing second derivatives, just using the first derivative case. Okay, so I hope it is clear. I hope you can complete it. Okay, now we'll move forward. Okay, now we are done with the section, and one or two problems are remaining in which we have some word problems. Okay, just like your one variable case, they will give you some word problems like there's a rectangle with height this, height, breadth, like that, like that. You will have to find the maximum, minimum. Okay, we have not done such problems. Very simple thing. Nothing new is there. Only these concepts will apply. Okay, so we'll do a word problem also. The only thing in the word problem is you should know how to formulate the function. Only that thing is there, nothing more is there. You have to just formulate the function. Okay, nothing new is there. Once you have done formulating, you can easily check out the maxima and minimum. Okay, so the only issue in word problem is how to formulate the problem. Okay, so let us look at one problem here. Determine the dimensions of a rectangular box open at the top having volume of 32 feet cube and requiring the least amount of material for its construction. Okay, just read the question. What is given to you? They have given you that volume is actually 32. Okay, volume is actually 32, and you have to find the least amount of material for its construction. So what does that mean? The material is actually coming in the surface, so you have to find the least surface area. Okay, you have to find the least surface area here. Okay, so what will you do here? It's very simple. Suppose x is the length, y is the breadth, and z is the height. Okay, or you can take like L be the length, B be the breadth, H be the height, whatever may be. So no, suppose I'm taking X, Y, Z, you can say, and it is given to you that it is open at the top. Okay, so the top portion is not there. So what will you use? So your rectangular box will be like this. Okay, so this top portion is not there, so the bottom it will be xy will be there for surface area, and two other portions are there, so 2yz would be there plus 2xz would be there. Okay, except the top portion, these two regions would be there. So this is your surface area. You have to actually minimize this function. Okay, I hope it is clear. You have to minimize the surface area in this function. Nothing new is there. If you understood the meaning of the problem, it is very easy to formulate. Okay, they won't give you very big problems and only simple problems will be there. That is it. Okay, but this, if you look at this question, it has actually three variables. We have studied only maximum minimum for two variables. Okay, only that is there in your course. So what will you do? Okay, for that you have to convert this into a two variable case by using this result here. What is that result? The volume is given to be 32. So you know that x, y, z is equal to 32. From that you can reduce this to two variable case by giving substitution for any variable. Suppose I am putting z, my z would be simply be 32 by xy. You can also put x or y also, no issue. So ultimately your s will become xy plus 2y into 32 by xy, right, plus 2x into 32 by xy. So your function will become x is equal to xy plus 64 by xy plus 64 by xy. Okay, so this is your function. Sorry, not 64 by xy, so it is actually 64 by y and 64 by x, right? So it will be 64 by x plus 64 by y. Okay, so now it is very easy to find the maximum minimum. So this is not absolute maximum and minimum in this case. In these type of problems, so you have to check the relative maximum. You have to check the what you say, the secondary. You have to use a second derivative test to find whether the critical points are maximum minimum. So only two steps are there. Find the critical points by putting fx is equal to 0, fy is equal to 0. Once you get the critical points, you apply the second derivative test to find whether it's a relative maxima or minima. Only these type of things will be there in these type of problems. Okay, let us complete this problem. Okay, I hope the formulation is very clear to you. It's very simple, nothing big is there. It's a very simple thing. Just try it yourself also. Okay, I'll give you one homework also. Okay, so this is the question here. Okay, so this is the question. Now let us check out find out the maximum minimum of this function. Okay, so how will you find it out? You find the critical points. For that I need sx, I need sy. What is sx here? Sx is actually y. Okay, minus 64 by x square. Right, by take, because the derivative of 1 by x is minus 1 by x square, right? Yes, it's 1 minus. Okay, and similarly sy is actually x minus 64 by y square, right? So you have to equate both of them to 0 and so try to solve them. So what will you get? So when you will be getting y is equal to 64 by x square from the first equation, substitute the second one, you will be getting it as x is equal to 64 by y square, it is equal to 64 by x raised to 4, right? 64 square by x raised to 4. Okay, so when you simplify, I think you will be getting it as x is equal to x raised to 4 by 64, or you will have x into 1 minus x cube by 64 is equal to 0. Okay, so from this either your x is equal to 0 or your x cube is equal to 64. So either your x is equal to 0 or your x is equal to 4, right? Okay, now x is equal to 0, you can straight away avoid it, because in this problem you are actually talking about dimensions of a box, so there is no box with 0 length. Okay, so this you can straight away discard due to the physical nature of the problem. Okay, so x is equal to 0, 4 can be discarded, and when x is equal to 4, what is the value? Y value will be actually 64 by x square, which is nothing but 64 by 16, which is 4. Okay, so only one possible candidate for maximum minima is there, which is nothing but 4. 0 you can straight away discard. Okay, because if you apply 0, your y would become infinity, because when when the length of the box becomes 0, the would become infinity. So it's not a physical case, so you can just avoid it because it is not possible physically. Okay, so only this point is there. Okay, now we will check whether this point is a maximum or a minimum. Okay, so how will you do with that? You will go for the second derivative. So what are the second derivatives? One is your r. Your r is actually sxx. What is that? It is actually minus 64 into minus 2 by x cube, right? So it is x raised to minus 2, so it will be minus 2 into x raised to minus 2 minus 1, so it will be getting minus 60 minus 2 x cube, so it is actually minus 128 by x cube. Okay, similarly your t, which is actually sy is also due to symmetry, it will be minus 128 by y cube. That's the same function. Okay, notice your sxy, your sxy is actually basically 1. Okay, so what is your rt minus s square? Rt minus s square is actually 128 square by x cube y cube minus 1. Okay, so when you substitute the value 4, definitely this will become positive only, because 4 cube is actually 64, y cube is actually 64, so it will become 128 square by 64 into 64 minus 1. This will anyway be greater than 0, because I think it is actually 3, which carry out anyway it will be greater than 0, which is 3. Okay, and also your r value, what is your r value? Minus 128 by x cube, that is again negative. Okay, your r value is actually minus, okay, it's not minus, actually it's plus. Okay, please correct me, this is actually plus only. Okay, because both negative signs are coming. Okay, so your r value is actually positive here. Okay, because it is 128 by 64, which is 2 greater than 0. So your rt minus s square is greater than 0, your r is greater than 0, that means the 0.44 is a minimum. Okay, so 4 minimizes the function, so you can substitute the 4 here. So your value of x is 4, your value of y is 4. What is your value of z? Z is actually 32 by xy, so it is actually 2. So these are the dimensions. 4, 2 are the dimensions which minimizes the surface area, and also you can find out the minimum surface area which is substituting these values. Okay, so nothing new concept was used here, only the previous maxima, minima and the second derivative test was used to describe it here. Okay, you can try it out. Very simple. Please complete that problem. Okay, now I have given only one homework also. If you want, you can try that also. It's very simple thing here. So here a bit you need to know what's the formulations here. So if you look at the question, just read the question here. You are having a rectangular boxes whose some length and birth, it's actually girth here is given here. Okay, so how will you formulate this problem? You have to actually magnify the volume. So you have to maximize the volume here. Okay, so rectangular box, the volume would be simply be x, y, z. Okay, now you have to maximize x, y, z. It's a 2 variable case, you have to convert into 2 variable by using this problem. Okay, so what is this? Okay, so here actually you are being given the length. Suppose your length is x, breadth is y, and height is z. So what will this become? This will become sum of whose length. So sum of x plus, now if you are taking a rectangular box here, just think, so this is the length, and if you are taking a cross section here, okay, so cross section would be a, basically you can see that it's a rectangle there with dimensions of the rectangle would be the height h and also the width z. Okay, width b. So it will be simply you can say the width will be basically, here I am taking y, height is actually z. So a perimeter of that cross section, they are talking of the perimeter of that cross section is actually 2y plus 2z, 2 into L plus b. So using that, so they have given you that x plus 2y plus 2z is equal to 108. Okay, it's given to you. From that you can try to formulate the problem. Okay, so please try it yourself. Okay, straightforward calculation only thing is that you should know how to formulate the problem. Okay, you can try some examples also. Okay, so summing up, we'll just sum up all the things which are discussed in the section of maximum, minima. Okay, everything is given to you here. Okay, so I hope that is also clear. Okay, so this module is over. So next class we will start with the next session, next module. Okay, thank you.